Okay, lecture 16. A lot of definitions here. Know those terms. And what are the common ions for the following elements? All right, so we go to the periodic table. Lithium is from group 1A, so that must be +1. Group 1A is always +1. Oxygen is in group 6. It's 2-. And these are the rules. I'm going to go through them as we move along, but you need to know these. Chlorine is in the halides. That's in group 7A. And so those are going to be, the common ion is going to be -1. Now, we can have chlorine with +1 or +2 or +7, but those aren't common. We want to go with the common ions. Ones that are most naturally, are easiest to form, the ones that you find naturally occurring in substances. Magnesium is in group 2A, so that's +2. If it forms an ion, it forms a +2 ion. Sulfur is in group 6A, just like oxygen, so that's 2-. Phosphorus is in group 5A, and that is going to normally be the phosphide ion, P3-. And then sodium is in group 1A, so sodium. So the big thing is making sure that you use the right symbols and know the proper ionic charge for these guys. So fluorine is in group 7, and we know that that is going to be a -1. And the reason is that if we add 1 electron to the fluorine, it's in group 7. If we add 1 electron, then it'll be very much like group 8. It'll be like a noble gas. So it prefers not to have an electron, but if it's going to have one, it wants to have enough to complete its octet. So it's really, in general, trying to complete the octet. So we're following the octet rule. Bromine is in group 7, so -1. Calcium is in group 2A. I should say 7A for bromine. Aluminum is in group 3. It loses 3 electrons to attain its octet in the level below. And then we have potassium is +1. Okay, now we're going to use this. So you need to know these ions. The rules are given in the book. I've really gone through them all as far as the groups. And of course, the noble gases don't form ions. So we go from group 1A through group 7A. And I should actually make one note here. I didn't do group 4A, so if you have carbon, group 4A, you can have 4-, which is a carbide, and you can also have 4+, and both of them occur. So group 1A through 3A is +1, +2, +3. And then 7A is -1, 6A is -2, 5A is -3. But then when you get to group 4, it can go either way. It's on the same order of difficulty to add 4 electrons as to take them away. So normally we don't do a lot with group 4A, but it does come up. What are the formulas for the ionic compounds made up of the common ions of the elements listed? So if you had an ionic compound made of calcium and bromine, well, calcium is +2, bromine is -1. To balance those ions, we need two bromines, because it's a +2, -1. And we definitely get, we want to get past the crisscross method, but let's mention it anyway because it's mentioned in earlier classes. This would be -1. So if we take the 2 here, put it down here, and the 1 here, then we see we end up Ca1, Br2. And the reason it works is that it's just giving us the ratio of ions we'd need so that the charges match up. So we have 1 +2 and 2 -1. So it's okay to use that crisscross method as long as you understand why you're doing it. So let's continue on here. Lithium and oxygen. Lithium is +1. Oxygen is -2. Well, you have a -2 here and a +1. So you're going to need 2 of these to balance that charge. And remember, an ionic compound has to be neutral. You can't have a compound that has a charge on it. It can't just be sitting around with a charge. It has to be balanced in some way. Even if the ions are loose in solution, there's the same number of counter ions to match them up, even if they are floating around free. Overall, it's a neutral charge. So we have that. Aluminum is +3. Nitrogen is -3, the nitride ion. So we have an even We have the same positives as we have negatives, so ALN. And just make sure with the symbols that you're using the proper case, lowercase or uppercase. Magnesium is +2. This one is probably the trickiest one, phosphide. And this is where students in the lower class would, 1050 would use the crisscross method. And you can certainly do that. You have the 2 here, 3 here, you have magnesium. But let's think about what we're doing here. If we have magnesium is +2, and phosphorus is, the phosphide is -3. So if we make it Mg2, then we'd end up, this would be a +1. See, we have a smaller positive number than the negative, so if we double this to try to get to -3, we won't be able to do it. So if we then double the phosphide, what would we have then? We'd have a -2. So still, we wouldn't have a neutral compound. So we did that. We doubled the magnesium, then we added a phosphorus. Now add another magnesium. There. It's neutral. And it goes by, we have 3 +2 charges and 2 -3 charges, neutral. Everything's cool. So that's why we're doing it. So the crisscross method does work, but make sure you understand why. Then we have +1, and sulfur is -2. And actually, go up to the lithium and oxygen. Lithium isn't from group 1A, oxygen is from group 6A, sodium isn't from group 1A, sulfur is from group 6A, so you should get the same ratio, 2 to 1. So we have lithium, 2 lithiums and 1 oxygen, 2 sodiums and 1 sulfide. From the same groups, you should get that same ratio.